The tokens example listing 5-2 shows the method for creating tokens from strings. The basic technique works with any phrase, string, or series of strings. You will normally process the tokens once you finish creating them. Listing 5-2, creating tokens from strings. Hashtag include IOStream. Hashtag include boost tokenizer.hpp. Using namespace standard, using namespace boost, main, into main. Define the test string. String my string equals this is a test string. Obtain tokens from the string. Tokenizer. Tokens my string. Display each token on screen. Tokenizer. Iterator. Iterate. For iterate equals tokens.begin. Iterate does not equal tokens.end. Iterate plus plus. See out. Start iterate. In line. Return 0. The tokenizer template places the tokenized form of my string in tokens. The application now has a set of tokens with which to work. To see the tokens, you must iterate through them by creating a tokenizer iterate. The application uses iterator to output the individual tokens. When you run this application, you see the following output. Okay, so it uses the tokenizer iterator to iterate, and then the output is this is a test string. Tip. This example shows a basic routine you can use for just about any need. However, you might need some of the extended capabilities of the tokenizer class. Check out the materials at http://www.boostaorg/libs/1_5/510/libs/tokenizer/index.html for more information about both the tokenizer and the tokenizer iterator. Performing numeric conversion. Numeric conversion isn't hard to perform. It's accurate numeric conversion that's hard to perform. Getting the right result as you move from one type of number to another is essential. Sure, you probably won't notice too much if your game score is off by a point or two, but you'll definitely notice the missing dollars from your savings account. Worse yet, when you finally get to take that rocket into space, a running error can definitely ruin your day as you head off toward the sun rather than planet Earth. The Boost library includes the converter template, which makes converting from one kind of number to another relatively easy. The converter template includes all the kinds of flexibility. The convert example shown in listing 5-3 presents two different levels of converter template usage, but really only scratches the surface of an infinitely more complex Boost library feature. Listing 5-3. Hi, Big Berry. Thanks for saying hi. Listing 5-3, converting from double to int. Hashtag include IOStream. Hashtag include boost numeric conversion converter.hpp. Using namespace standard. Using namespace boost. Using namespace boost. Numeric. Int main. Create the converter. Type def converter int double to int. Listing 5-3 continued. Define the variables for the example. Double my double equals 2.1. Int my int equals double to int convert my double. Oh, thank you, Pink Fairy. Display the results. See out the double value is my double in line. See out the int value is my int in line. See what happens with a larger value. My double equals 3.8. My int equals double to int. Convert my double. See out the double value is my double in line. See out, the int value is my int inline. We don't want truncation, so let's round. Type def conversion underscore traits int double traits. Type def converter int double traits. Def underscore overflow underscore handler. Round, even, double, double to rounded. My int equals double to rounded, colon, colon, convert my double. See out, the int value is my int inline, return 0. Why numeric conversion is necessary? Humans don't differentiate between one kind of number and another. Seeing 1 is about the same as seeing 1.0. The computer, however, does make a differentiation between numbers at 2 levels: integer versus floating point, and size. The integer part of the equation comes into play because of the early processors and PCs, which could perform only integer math. For floating point math, you had to buy a separate math coprocessor. Today, the math coprocessor comes with the processor, but integer and floating point math still occur in different areas of the processor. When the processor performs integer math, it uses different registers and capabilities than when it performs floating point math. So the conversion between integer and floating point data is more than philosophical. It involves using physically different areas of the processor. The size issue determines how large the integer or floating point value is. Again, the difference is physical. Early processors could handle only 8 bits of data at a time, then 16 bits, and so on to 32 bits, and finally the 64 bits of today. Using larger numbers in older processors required a number of additional tasks in software, so using larger numbers incurred a significant performance penalty. Today, with memory and processor register size no longer a concern, large numbers are also no longer a concern, except that you must observe the historical reasons for using numbers of a specific size. In addition, there are sometimes benefits from a reliability, security, or speed perspective in using a smaller number. The important consideration in working with numbers is that you must observe the correct conversion techniques when you want to obtain the correct results. The example begins by creating, back to the example that other part was inside. The example begins by creating a converter object double to int. This first object shows a minimum information you can provide. Shows the minimum information you can provide. The target int and source double values. The default setting truncates floating point values, float and double among them to obtain an int value. To perform a conversion, the code relies on the convert method, which requires a variable of the required source type as an argument. Remember, the converter template includes support for 4 kinds of rounding. You must use the correct kind of rounding to match your application requirements. Imagine that what would happen to calculations if you used truncation when rounding is really Imagine what would happen to calculations if you use truncation when rounding is really the required operation. The following list describes all 4 kinds of rounding and that converter supports. Trunc removes the decimal portion of the value, rounds toward 0. Round even rounds value up or down as needed. Seal rounds the value up toward positive infinity when the decimal portion is greater than 0. Floor rounds the value down toward negative infinity when the decimal portion is greater than 0. The second converter object, double to rounded, shows the template requirements to choose the kind of rounding that the object performs. In this case, you supply 5 arguments to the template. The converter template actually accepts up to 7 arguments. Discover more about them at http Target source conversion underscore traits, which include the target and source types as a minimum. Overflow handler, which determines how the object handles conversions that result in an overflow. The default is def underscore overflow underscore handler rounding template object, which includes the rounding source type. The process for using the extended form of the converter template is the same as the simple form shown earlier in the example. However, you must now create a conversions underscore traits object, traits in this case, and provide the required input information. See more examples of using conversion underscore traits at https://www.boost.org/libs/numeric/conversion/conversion underscore traits underscore traits underscore class.html. As before, you rely on the convert method to perform the conversion process. Here is the output you see when you run the application. The double value is 2.1, the int value is 2, the double value is 3.8, the int value is 3, the int value is 4. Note that the last two lines show the difference in rounding. The value 3.8 in the first case, you see the default trunk, and in the second, you see the effects of round even. Discover more about performing numeric conversion using Boost at http://www.boost.org/libs/1_5_0/libs/libs/libs/libs/libs/libs/index.html. Whew! On that note, as much as I'd love to just keep it going, I'm too kind of tired of this. But the good news is we're ending here tonight on page 776, and this chapter ends at page 782. 6 more pages. I wish. But the goal then is the next time I read to go ahead and finish those last 6 pages, but also either stop there if I'm not feeling like reading past that, and then wait to start working on reading the appendix like in a different stream, or continue on with at least some, if not all, of the appendix. Either way, this is pretty much it. We're almost done with this book. Again, this has been a reading. I didn't start reading here as a streaming thing, but I pretty much toward the start of the book. And this particular book is C On For Dummies, 3rd edition, as written by John Paul Miller and Jeff Coxwell. So I'm going to go ahead and go because I'm really getting hungry and just kind of bored of reading and sitting around. I just don't like doing a lot of that for long. And plus, I need to eat something for dinner. Plus, I kept turning on green screen by accident. So I'm going to go ahead and I'm going to test this out. And then I'll close out the stream. But I did put a couple of photos in, so I'm hoping that now that I put a couple of photos in, I'll be able to turn off green screen. I mean, that's a very weird thing, but if that's the way to do it, that's fine. But at least now if I get stuck having green screen, it's not that I have to start the screen and stream again because I'm pretty much done streaming this. I might do some dancing. We'll see. Probably like a quick bit of dancing. I do have a request I want to be able to meet. That's true. I'm hoping like doing some Kingdom Hearts time would be fun. That would be really fun. I would really like to do some Kingdom Hearts time. So we'll see. Right now I gotta go eat some dinner time. But let me test out my theory with this green screen thing. Let's see. Turn it on. And now I can turn it off again. Beautiful. That's much more the way I like it. Okay. Yay. All right. So, in case you're interested, I'm likely going to have something like this for dinner. That's probably going to be dinner tonight too. That was dinner on Thursday, so that's probably dinner tonight too. So yay for dinner time. I'm going to go ahead and do that, and yay for being able to get the green screen off quick enough and not have to just stop my stream because that's annoying. Anyway, thank you so much for everybody who checked out any of these 3 streams that I just did for C++ for Dummies. And that includes BigQuery. And thank you to anyone who might check out any or all of these in the future, should things have happened, and wherever, however, whatever. Just make the most of it. That's the most important part. Bye-bye.